Alrighty, so now for part 2 of our video talking about lenses. In our last video, we talked about our converging lenses and how they are going to construct ray diagrams. Now we're going to start focusing on our diverging lenses. So again, I really just wanted to quickly focus on the idea of a converging lens versus a diverging lens and really why we are seeing them do what they do. So we're really just going to focus on the diverging lenses for this one here. In the last video, I did give an example of our light waves coming into these individual lenses, right? So oftentimes what we're going to do is we're going to indicate our light waves as being these kind of upright parallel lines. And as they are going to contact the surface of that individual lens, again, we are seeing that at this point, the individual light wave is still passing through the air. So it's passing at its original speed. Whereas the bottom side of this individual light wave is now entering into the lens. And we know that as things are passing through things like plastic, glass, water, or anything like that, right, the speed that those individual electromagnetic waves are passing at is going to slow down. And so we used the pen example before, and I'll use it once again. When that individual wave is passing through, we're seeing that the bottom side of that wave is going to contact the lens and slow down before the top. And so again, if we are passing that through, we are going to see that as that slows down, it is ever so slightly going to change the direction of that wave. And it is going to start moving slightly downwards towards the edge of this individual lens. And then we're going to see that as that comes out of the lens, we are now going to see that this top side of the wave is now going to return to its original speed. So it's going to speed up, whereas the bottom side of that individual wave is still traveling at that slower speed, passing through that individual medium. So now, again, when that's passing through, the bottom side is still moving slowly, and our top side is going to move a little bit faster. And that's going to cause where we see that kind of refraction or that bending of our light away from where our principal axis would be. So just kind of a quick little refresher so you kind of have an idea on why these things are doing what they're doing. So when we get into our diverging mirrors versus our diverging lenses, again, very similarly to what we saw in our previous examples, we're going to be able to see a lot of consistency between these two things. So we saw that in our diverging mirrors, our individual reflected rays are going to kind of do the opposite as what we saw in our converging mirrors. Instead of moving towards the principal axis, the reflected rays are now going to be reflected away from that principal axis. So we can see here, I have a couple examples of where parallel rays would be coming into that mirror. Now we know that those, even if I just look at the surface of the mirror, if the surface of the mirror is kind of on this angle, we know that just based off of our simple understanding of laws of reflection, if that is coming in here, it is obviously going to reflect in that direction. Now we know from our examples with our diverging mirrors that it's going to reflect at a very specific angle, and that angle is going to be related to our focal point. So we saw that if we were to draw a line or a ray of or a reflected ray from that individual incident ray, it is going to reflect away from the mirror in respect to the angle of where our focal point would be. All right, so imagining that that focal point was there, the reflected ray is going away, but in order to figure out that angle, we need that kind of backside of our mirror to have that line directly towards it. Right, and we could see that exact same example down here with this incident ray. So this one passing here parallel to the principal axis. We know that that reflected ray is going to pass directly away from the principal axis, right, in relation to where the focal point is on the virtual side of the mirror, right? So these two would be my reflected rays, right? So if a object is traveling parallel to the principal axis, it is going to be reflected away from the principal axis in relation to where this focal point is, right? Now we have a couple other examples that are incident rays traveling as if they were to go directly through this focal point. And we know that if they were to contact the surface of that mirror, based off of the angle that they are on, they are going to reflect parallel to the principal axis. And we also drew our dotted lines backwards into the virtual side of the mirror. So this here would be a reflected ray, as well as in this scenario, a reflected ray would be traveling parallel to the principal axis with our dotted lines continuing it. Right, so that is just a quick little refresher of our diverging mirrors. So now what we're going to do is we're going to look at our diverging lenses. So when we look at our diverging lenses, right, the very similar process is going to occur. The refracted ray that is going to pass through this mirror is going to then be refracted away from the principal axis. We saw that in our first example. It's going to be going up in this direction. However, we are going to use one of our focal points in order to figure out the exact angle that that refracted ray is going to pass on. And that is going to be our F prime. So if we have a parallel line to the principal axis, or a parallel ray for our incident ray going into that individual lens, it is going to refract away from the principal axis. But the exact direction that that is going to go on is going to be related to our F prime, or our focal point on our side of the lens. So it is going to be refracted in this direction. However, there's also going to be a reflected ray that is going to come back and pass through that original focal point. So this here is going to be what we call our refracted ray. But we are also going to have this dotted line here, which is going to, I'll just kind of note that down here, is going to represent a reflected ray. So unlike our examples where we're using converging lenses, now we're actually going to have three types of rays. We have our incident ray, we have a refracted ray, and now we're also going to have a reflected ray. Right, so just something to kind of keep in mind as we move forward. And the exact same thing would be true if we were looking at this individual incident ray, right? It is parallel to the principal axis, so it is going to reflect away from that principal axis. So the refracted ray is going to go in this direction, and the reflected ray is coming back towards that individual focal point. Right, so again, this here is refracted, whereas the dotted line is reflected, right? And then we can see these same properties going through if we look at these individual lines here, or these incident rays. They are approaching that individual lens as if they were to go through our F2 prime or our F prime prime. Now, when we have that occurring, those are going to reflect off of that, the refracted ray, the reflected ray is going to come backwards, right, parallel to the principal axis, and the refracted ray is also going to continue parallel to the principal axis. Okay, so those two are actually going to reflect in the same direction as one another. And then finally, here, if I were to do that example as well, right, the refracted ray is going to travel parallel to the principal axis, and so will the reflected ray. Okay, so this one's just a little bit different because we are adding that additional ray. So now we're dealing with all three rays that we've seen: incident, refracted, and reflected. Right, so we are going to kind of jump forward, right? Again, remembering the difference between reflection and refraction. Okay, refraction is the bending of light, but it is still the original light wave that we were working with at the first place. However, reflection, right, that is a different light wave that we're going to see. And really, this is going to be why now in lenses, we're going to see that the image that is appearing on the same side of the object is now going to be virtual, whereas the objects appearing on the opposite side of that lens are going to be real. That is because these are individual reflected rays. They're not necessarily the real or the original light wave that is passing through that lens. So we are going to get into, again, our rules that we are going to follow if we are going to create a ray diagram for one of these scenarios. So when we are looking at this, all right, our first rule, as we have done in all of our other examples, is going to begin with a ray parallel, so an incident ray parallel to the principal axis. So if I have a ray that is coming parallel to the principal axis from the point of my object, again, starting at the point of the object, trying to make it as parallel as possible, coming into that individual lens. Right, so again, this here is an incident ray. It is going to have kind of two scenarios now, right? The refracted ray is going to move in a direction away from the principal axis in relation to our original focal point. So here, if I am starting here, my refracted ray is going to move on a plane away from the principal axis. Right? So this here is my refracted ray. Whereas the reflected ray is going to move and travel backwards, oh sorry, that should be a dotted line, through F prime. So the refracted ray travels away from the principal axis in the same pathway as F prime. The reflected ray, which is our dotted line here, will reflect back through F prime, which is our focal point. Right, so that is our first rule. Now, our second rule that we are going to see here is talking again about this optical center. So the point at which the center of our lens is coming into contact with the principal axis. So if we have a ray that is passing through the optical center, right, we are going to see that it is not going to deviate from its original path whatsoever, right? So if we have that, we are going to see that an incident ray passing through the optical center will not refract or reflect. So that individual ray is just going to continue straight on through with zero deviation whatsoever. So I'm just going to draw that incident ray, and that is just going to continue onwards. It is not refracting at all, and it is not reflecting. Okay, it is just continuing straight through. And then finally, our third rule that we are going to see is that if a ray is going to pass, or if an incident ray is passing on the direction of F2 to F2 prime or F prime prime, it is going to then reflect and refract along or parallel to the principal axis. Okay, so if we're going through, right, if you draw a line, so an incident ray traveling towards F2 prime, right, which again, remember, is our focal point beyond the lens. The reflected ray will travel parallel to the principal axis back towards the object, and our refracted ray will travel parallel as well to the principal axis. But it is going away from the object. And so if I am to go through that process, right, assuming that the original incident ray is traveling from the point of our object here and going to be traveling towards our F2 prime, we're going to see that we're going to stop that ray at the center of our lens, and then that individual ray is going to be both reflected and refracted. The refracted ray is going to continue parallel to the principal axis, away from the object, whereas the reflected ray is going to travel back towards the object. Okay, so remember, these dotted lines, again, are reflected, and this ray here is refracted. Now we do notice that if we were to look at this scenario here, right, on the opposite side, or sorry, on the real side of that individual lens, these rays are never going to cross over or intersect with one another, right? They are diverting away from one another. So it's going to be impossible to form an image on this side of the mirror, right? Where we are going to see rays converging is right over here. Okay? So if I look on the same side of the mirror, we are going to see that I have the reflected ray from step 1, the reflected ray from step 3, as well as the incident ray from step 2. And all of those are going to converge at one specific point. So that is going to represent where our image is going to be located. So my image will be right here with the point of the arrow being at the location where all three of those lines are going to converge. And what we talked about in our last video, because these are reflected rays, they're not actually the original rays that we're working with. That is what we're going to call a virtual image. So just remember, these are kind of opposite of what we noticed in our mirrors. In our mirrors, we saw that everything going to be on the same side of the object, the same side of the mirror as the object were considered real. However, in this scenario, it's flipped back and forth. So just remember that with lenses and mirrors, right? Instead of having the real image on this side, it is now going to be considered virtual if it is on the same side of the lens as the object, and it would be considered real if it was on the opposite side of the lens as the object, right? And at this point in time, right, we will notice that we kind of see where that image would be located. Right, so at this point in time, you can start your assignment and kind of get working on that. I am going to go through one more example here for you, just so if you would like to, you can follow along as you're completing your assignment, just kind of seeing how everything works one more time. So I'm just going to start right from the start. Again, looking back here, we are seeing that our very first step is going to draw our parallel line with our refracted ray as well as the reflected ray. Right, so I'm going to go ahead and do that. If you want to, after each step I do here, you can pause the video, do it on your sheet, and then come back to the video afterwards. So I'm going to start by drawing my parallel line to the principal axis, right? And try and be as accurate as possible when you're drawing these individual parallel lines. So starting off, I have my parallel line going directly to the middle of the lens, okay? So again, this is an incident ray. Now trying to figure out where the refracted ray is going to be. Now this one's not really going to be very representative of the lens I drew, but it's not really going to make a difference. Remembering that the refracted ray is going to divert away from the principal axis on the pathway where it would pass through F prime. So if we can see back here, F prime is back here. So I'm going to take that. That is going to be my refracted ray. And then my reflected ray is going to pass backwards through F prime, or my focal point. Right? So again, this up here, right, my solid line beyond the lens itself is going to be refracted, whereas this one here is going to be reflected. Okay, so that is our first step. So if you want to, you can pause the video now, complete this on your worksheet, and then come back to the video for the second part. Once we finish that, right, our second thing that we have to do is involving the optical center. So just like we saw in our converging lenses, we are going to draw an incident ray passing from the point of our object through the optical center, which again is the point where the center of the lens is going to come into contact with the principal axis. So I'm going to draw my incident ray there. It is not going to be refracted at all. It is going to continue on in the exact same direction that it started, okay? And then finally, right, for the third line I'm going to do, right? So again, if you want to, pause the video here and then come back for our third step. Our third step is going to be starting at our point of our object again, and we are drawing an incident ray that would pass through F2 or F2 prime if it were able to pass through this individual lens unrefracted. But we know that's not possible, so we're only going to draw that incident ray until we contact the center of the mirror. So again, this is an incident ray. And now we know that that is going to both reflect and refract off of the surface of that lens in the same direction, which is going to be parallel to the principal axis. Again, the refracted ray is traveling away from where our object is. The reflected ray is going to reflect back to the location where our object would be. Okay, so again, this here is refracted. This here is reflected. Right, and I'll just draw that in for our green one as well, just so you don't get mixed up. Okay, that is reflected. Right, so once you have reached this point, again, you are going to notice that there is one location where three of our individual rays are going to converge, right? So we see right here, right, I have the two of our reflected rays as well as my incident ray all passing through the very same point. So that is going to be where the point of our arrow is going to be located. Right, so now you will notice that in this scenario, as well as the past scenario that we did, right, in both scenarios, the image that is created is going to be virtual. It is going to be noticeably smaller than the object, right? It is going to be on the same side of the individual lens as the object itself, right? And it is going to be upright, right? In both scenarios, it is going to be upright. So I want you to play around with it, do the worksheet, right? You may notice that there may be some differences in these, or you may notice that the overall outcome from a variety of different locations and objects might all be the exact same. So complete the worksheet, right? Play around with that. But you will see some pretty similar outcomes regardless of where that original object is located. Okay, so that is it for this video. Hopefully it helped. And if you have any questions, send me an email and I can help you out.